The question says that in a chamber, a uniform magnetic field of 6.5 G, where 1 G stands for 10 to the power minus 4 Tesla, is maintained. An electron is shot into the field with a speed of 4.8 into 10 to the power 6 meter per second, normal to the field. Explain why the path of the electron is a circle and determine the radius of circular orbit, given that E is 1.5 into 10 to the power minus 19 coulomb and mass of electron is 9.1 into 10 to the power minus 31 kg. Here E is charge on electron, and we know that it is 1.6 into 10 to the power minus 19, but in the question it is given 1.5. We will be using 1.6 into 10 to the power minus 19 coulomb. The total force on a charge moving with the velocity v in the presence of magnetic and electric field B and E respectively is called the Lorentz force, and it is given by Q times V cross B, which is the magnetic force, and Q times E, that is the electric force. Now in this scenario there is no any other charge particle, so we can neglect this force and we will solely focus on this magnetic force, that is Q times V cross B. This force is perpendicular to both velocity and the magnetic field. A charged particle entering the field with a velocity perpendicular to the field moves in a circular path due to the centripetal force provided by the magnetic force. Now since this force is perpendicular to the initial velocity, so this force will act as a centripetal force. Now that will enable the particle to move in a circular path. So force, the magnetic force which is acting as a centripetal force is given by Q times V times B. R will come out to be mv by qb, where m is the mass of electron and E is the charge on electron and V is the velocity of electron and B is the magnetic field. Now substituting this, we will get a radius of 4.2 centimeter. So the radius of the circular motion that the charge will encounter is going to be 4.2 centimeter. Thank you.